In this next example, we're going to use our information about free fall. Remember, when you see the words free fall, it means ignore air resistance, and the acceleration due to gravity is negative 9.8 meters per second squared j hat, meaning 9.8 meters per second squared directed downward. Okay, acceleration in free fall problems never changes. So if you throw something up in the air and then it falls back into your hand, the acceleration is always negative 9.8 meters per second squared j hat. Okay, so even at the top when it stops, the acceleration is still negative 9.8 meters per second squared j hat. Okay, so let's go ahead and get started on this problem. A coin is tossed in the air with an initial velocity of, we need to look that up, an initial velocity of 5.2 meters per second j hat. How high does it go? If the ground is 2.13 meters below the toss height, how long does it take to hit the ground? So we have two problems here that we have to solve. Notice they don't seem to give us a lot of information, but believe it or not, it is enough. Okay, so the first thing I know is that, I am tossing this. So I'm going to go ahead and write in my information, my initial position, my final position, my initial velocity, my final velocity, my acceleration, and t. Now, here's the thing. Because this is in the y direction, I'm going to change this right here. It just makes it easier for me. You don't need to, but please be careful and make sure you understand that in free fall problems, this is really g. Okay, and so we're going to automatically put this in 9.8 meters per second squared j hat. It can't change. It is what it is. Okay, first thing I want to know is how high does it go? Okay, and I want, let's see, how high does it go? Now, how fast is it going when it reaches its maximum height? Hopefully you said 0. It does stop when it reaches its maximum height. So I'm going to put in 0 meters per second here. Now, for the initial velocity, it's 5.2. 5.2 meters per second j hat. And I'm going to assume, because I haven't been given the rest of this information, I'm going to assume that my initial position is 0. Okay, because it's asking how high does it go. We can choose how high it goes from what? Is it from our hand or is it from the ground? I'm going to choose from my hand. How high does it go from my hand? Now, you'll need to specify that when you take your AP exam. Okay, notice I don't have time. I put an X in it. So now, what does my motion diagram look like? Well, the first thing I'm going to do is draw my velocity vectors. Okay, so it's tossed up at some initial velocity, and then it goes smaller and smaller until it stops. And so I'm going to go ahead and get a red dot at the top. There we go. Okay, so that's my velocity. Next, I need my acceleration. Remember, acceleration is a constant, so it is going to be directed downward, and I'm going to be calling that g. Okay, so that's my motion diagram. I have an extra vector here. You don't need to have that many. I just got excited. Okay, so for the first part, this is what my motion diagram looks like. That tells me I should have a velocity changing, and I should have acceleration. Okay, looking at my my sheet here, I go down t until I hit 0, and there's my equation. Okay, so I'm going to go back. Okay, so I'm going to write out the equation. It's v, let's see, v final squared minus v initial squared equals 2a, sorry, g delta d. You could use y if you wanted, delta y. Okay, I'm going to solve for delta d. Delta D is then equal to V final squared minus V initial squared over 2G. My final velocity is 0, so I'm going to write that in. Delta D is equal to 0 meters squared per second squared J hat squared minus, sorry, I need more space here. Let me see if I can get that thing to come up. I can't. Okay, so we're going to have to crunch it in here. And then my initial velocity, let's look in our box, 5.2. So it's 5.2 meters per second J hat quantity squared. And then I'm dividing by plus 2 times negative 9.8 meters per second squared J hat. Okay, I'm going to start crossing out like terms. I've got a J hat here, I've got one here, and I'm going to have one here. My meters cancel out with a meter, which cancels out with one of the meters here. I'm going to do that. And I got second squared, and that's going to be a second squared, and they cancel out. Okay, so I should be left with meters, and sure enough, I am. Okay, so putting this in my calculator, I end up with negative 5.2. I'm sorry, I'm going to square the 5.2 first. 5.2 squared, and that gives me 27. And then I'm going to make that negative because we have a negative right here. Don't forget this one right here. See the negative right there? Don't forget that. Okay? And then I'm going to divide that number by negative 2 in parentheses times 9.8. Okay, so that gives me a displacement, and I wish I could actually put it in here, but I can't. I don't have, oh, there it is. Very good. Okay, so putting my answer in here, I end up with, sorry, delta D is equal to, let's see, I need 2 sig figs. Now, be careful. See this right here? That's a constant. Constants do not have sig figs. Never, ever, ever use 9.8 to determine your sig figs for your answer, or any constant for that matter. Okay, be very careful about that. Okay, this has 2 sig figs, this number right here. So that gives me 2 sig figs for my answer, so it's 1.4 meters J hat. So it goes up 1.4 meters from my hand. Okay, now for part B, this is where it gets tricky, I've got to do another set of boxes. Okay, so here's what I'm going to do. I'm going to cheat, but you should already have those boxes. I'm going to copy, and then I'm going to paste. So it makes it easy for me. Okay, so filling in my boxes again, I have D initial, D final, V initial, V final, G, T. I have negative 9.8 meters per second squared J hat. Here, let's see what happens here in this problem. For this part, it says, how long does it take to hit the ground? So that's a time. I mean, how long, you usually think length. And remember that from our initial lectures. You got to be careful because a lot of problems are worded this way. How long does it take? So that's actually a time. And it says if the ground is 2.13 meters below the toss height. Okay, so my initial position is 2.13 meters J hat. My final position is going to be 0 because it hits the ground. My initial velocity is still the same velocity. It's going to be the 5.2. So 5.2 meters per second J hat. I want the time. Here's the thing though. Be careful. A lot of students right away say the final velocity is 0 because it hits the ground. After it hits the ground, its velocity is 0. But what does it hit the ground with? Okay? Think of it this way. It's got to have some velocity when it hits. If you lay on the ground and you toss a ball up and you don't catch it, it's going to hit you. Okay? And it will hurt. And it wouldn't hurt if it had a velocity of 0. Okay? So it does eventually stop, but it doesn't hit with a 0 velocity. Okay, motion diagram. This gets a little tricky, so let me show you. You're going to have your initial velocity, and then it's going to stop, and then it's going to start coming back down. Okay, notice from my motion diagram also that my motion diagram does not have a zero final velocity. It gets longer and longer. Okay, my acceleration, I'm just going to draw it by hand. I apologize for my sloppiness. Okay, so there you go. That's your motion diagram. So now what we're going to do is look at our formula. We have V final blanked out. So let's go to the formula sheet. We're going to go to V final, go down the V final column. Notice here, it's this formula right here. Okay, so we're going to be using a quadratic. Oops, I went too far. Okay, so we end up with, let's write that out. I end up with delta D is equal to VIT plus 1/2 GT squared. Be careful. A lot of students will say, wait a minute, G is negative. That should be minus 1/2. Notice I have a vector sign over the G. That tells me that the number I replace with that G vector sign is going to be the negative 9.8 meters per second squared J hat. That negative J hat tells you it's going down. Okay, so let's go ahead and solve for this. Now this is a little bit tricky. Our initial velocity is not 0, which would have been nice. It would have canceled out that middle term. Our G is not 0, so that term stays the same. Our displacement is not 0, so that still makes it complicated. Okay, this is definitely going to be a quadratic. Okay, and so in order to solve for time, it's going to be the formula minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, where the A, B, and C have nothing to do with the formula above as far as variables. It's just a generic equation. Okay, so let's go ahead and substitute in our numbers. Now, I'm just going to tell you right now, I am not going to substitute in the units and the unit vectors. This is too complicated for that. Okay, we're just going to substitute it in and come up with an answer. Okay, so I have t is equal to what? Now I need to write this equation with the numbers in it. So let me go ahead and do that. And I'm going to take this delta d over to the other side. I hope that doesn't confuse anybody. Okay, so let me write that out for you. I have 1/2 gt squared plus VIT minus delta d equals 0. Okay? Now let's substitute in the numbers. I get 1/2 times negative 9.8 meters per second squared J hat T squared plus my initial velocity, which in this case is 5.2 meters per second J hat times T minus final minus initial 0 meters J hat minus the 2.13 meters J hat. Okay, so now I'm ready to actually solve for the answer or the numbers. Okay, so for A, it's going to be 0.5 times negative 9.8. And so the t squared term, so I have 0 equals 4.9, sorry, negative 4.9 t squared plus 5.2 t plus 2.13. Okay, so this is A, this is B, this is C. Okay, if you have a calculator that actually has formulas in it, you could actually just go ahead and put this in the formula. You can also find software online that will do this for you, but I'm going to have to do it by hand because I don't have any of those things. Okay, so let's go ahead and solve for t. I have t equals minus b. So b is 5.2. So that's minus 5.2 plus or minus the square root of 5.2 squared minus 4 times negative 4.9 times 2.13 all over 2 times negative 4.9. Okay, so now what I'm going to do is I'm going to go ahead and solve for the inside stuff. So I end up with t equals negative 5.2 plus or minus. Now I end up with 5.2 squared, okay, minus 4 times negative 4.9 times 2.13. And that gives me 68.7-ish. I'm going to take the square root of that number, and that gives me 8.3. 8.3. And I'm going to take the negative 4.9 times 2, and that gives me negative 9.8. I should have known that. I'm tired. Okay, negative 9.8. Now, we're going to go ahead and solve this. If you get a negative root, you throw it away. So we take negative 5.2 plus 8.3 divided by negative 9.8, and that gives me a negative time. Okay, so that did not work. Okay, so I get two answers. The first one is negative 0.32. Okay, the second answer is when I do the minus. So I take negative 5.2 minus 8.3 equals, divide that by negative 9.8, and I get 1.34 seconds or 1.4 seconds. Okay, so we're going to cancel out this root because it's negative. You can't have negative time. So the time is going to be 1.4 seconds. Okay, this is very complicated. I don't believe you're going to ever see anything like this on the AP exam. But just in case, this is how you would solve it. Okay, so this is almost like a worst case scenario kind of problem of what you could see on the AP exam. Okay, so now at least you know what to do if that happens. Again, if you have any questions about this problem, you can rewatch the video or write down your questions in your notebook and make sure you ask me next class.